Alright, we are on to exercise number 3 of the volume and total surface area of a pyramid notes. And we have a right regular pentagonal pyramid with an apothem of 8. We need to determine the lateral area. And we also know that the angle formed by the slant height on the apothem is 60 degrees. And our goal is to round to the nearest tenth. So if we could kind of picture this pentagonal pyramid. It's regular, so we have a regular pentagon base. So I'm going to just draw 3 sides of that pentagon base. I'll draw like the lateral faces, draw 3 of them. Okay, and then the 4th and the 5th would be like back here. If I kind of like drop down that segment, dotted line there, dotted line there, so we have like the 4th and the 5th triangle, isosceles triangles would be back there in this picture. So the lateral area, if we recall, is the area of the 5 congruent isosceles triangles in this problem. So 5 congruent isosceles triangles. Okay, so to get the area of the triangle, we need to know the base. Right, we need to know the base and the height. Okay, well the base of the triangle is the same thing as the base of the pentagon. So the base of the triangle is the base edge of the pentagonal pyramid, so it's just one side of the pentagon. Okay, so let's draw that pentagon and get a little bit of a clearer picture with that. Since it's already in there, let's just draw on the apothem of that. And the apothem of the pentagon is 8. Okay, so the apothem is 8. Okay, so the apothem splits the base edge in half. So we call that piece x, so then that piece would be x. We need to get each angle of the pentagon. So step 1, we can do 180 times 5 minus 2. Divide that by 5, and we can get each angle to be 108 degrees. So then when we draw in the radius, we would cut that 108 degrees into 54 and 54. So we get a 54 degree angle. We have a right triangle, so we have a 54-36 triangle. So when we cut that 108 in half, we'd have an angle of 54 degrees. So if I just draw that right triangle, I'm going to kind of enlarge it over here and put that right triangle here. We have a 54 degree angle. We have the apothem, which is 8, right? And our goal is to solve for the entire base edge, because that would be the base of my isosceles triangle. So we have x there. So we can do step 2 of this kind of part of the problem here would be the tangent of 54 is equal to the opposite side of 8 over the adjacent side of x. So that means x is going to equal 8 divided by the tangent of 54. So x is going to be approximately 5.812-ish, so about 5.812. We'll keep that into in the calculator. When we double that to get the entire base edge, so 2x would be approximately 11.62-ish. We'll call that about 11.624. We'll keep the rest in the calculator. All right. Okay, so we're getting closer to being done. Because if we can just get the height of the isosceles triangle, so I'm going to draw that in. If I could get the height of the isosceles triangle, then I have the base and the height, and I multiply it by 5, and I'm good. Well, remember from exercise number 1 that if it's a regular pentagonal base, then the slant height And the apothem would form a right triangle with the altitude. And I'll draw that right triangle in. So the altitude and the slant height with the apothem, and we already know the apothem is 8, forms a right triangle. Well, the directions told us that the angle formed by the apothem and the slant height was 60 degrees. Right? We also know the apothem is 8 units long. So since the apothem is 8 units long, and the altitude, the apothem, and the slant height form a right triangle, in this case we have a 30, 60, 90 triangle. And the apothem is across from the 30-degree angle. So that means that the altitude, in this case, if we needed to find it, would be 8 root 3, and the slant height would be 2 times the apothem, which would be 16. All right, so that means the lateral area, we already said it's 5 congruent isosceles triangles, so the lateral area is going to equal 5 multiplied by 1/2 of the base, which was about 11.624-ish. Keep that in the calculator, right? We have those extra digits in the calculator, multiplied by the height of the slant height, which would be the height of the isosceles triangle, which is 16. And then when I do that calculation, eight divided by, so from before I had kept 11.624-ish in my calculator. I'm multiplying that by 16, dividing that by 2, because it's 1/2 of 11.624 times 16. Okay, but then that's the area of one of them, but I have 5 of them. So the area of the 5 congruent isosceles triangles, which would be the lateral area, is approximately 465 if we round to the nearest tenth. And we could call that units squared, since they didn't tell us the units in the problem. All right, so that's exercise number 3.